We're at go-to-math.com. Let's click the calculus and go to inverse functions. Now, hopefully, you've already clicked on that and watched the introduction. My great artwork there. It's hard to draw on this tablet, but it gives you kind of a picture that you can hold in your mind of what's going on, and that's really important. Being able to look at that picture because that picture is actually going to help you remember the what we're doing here. I know it helps me. You want to put as many pictures, associate as many pictures uh, to this calculus or to any math really, because we think in pictures, or at least most people do anyway. And I think the reason for that is just because we see pictures. I mean, everything's a picture out there to us, right? Anyway, I'm writing this stuff down here. So when we go to the whiteboard, I'll remember what it says. So go 45 and f of x is equal to 5x squared. Okay, this is going to be really simple. I promise. Real simple. Let's move over to the whiteboard and let's. Okay, what color are we on? Oh, I don't like that color. How about just plain old black? We'll do that. So we want to find, this is what we want to do. We want to find f inverse, but this is the derivative of the inverse of x at a. And we're given a. A is equal to 45. And we're given f of x, which actually I'm going to write down here. So f of x is equal to 5x squared. Okay, pretty simple, right? Now, let me just attempt to maybe draw this. Attempt to draw this real quick. So we're going to say that this right here is, you know what? I think I drew, yeah. We're going to, okay, so that's 5x squared, and then its inverse, and we'll say this is the inverse. Okay, the inverse is something like that. We're out here at 45, so that's going to be somewhere out here. Alright, so we'll say 45 is right here. And what we're doing is now this, I should have made this a little steeper than what it looks, but anyway, what we're actually doing here is, since this is the inverse, alright, this is the inverse, and then this is up here is f of x. What this is asking us to do at 45, it's geometrically we can say that it's asking us to find the slope of the tangent line at this point right here, okay? The slope of the tangent line. And this curve actually kind of continues up. That's not a good drawing, but anyway. But what we're going to actually find is we're going to find the slope of the tangent line. We're going to find the slope of this tangent line is what we're going to end up finding, the slope of this tangent line right here. And once we find the slope of this tangent line, which we'll call that slope m, once we find the slope of this tangent line, then we'll easily be able to know what the slope of that tangent line is, because since these are both inverse functions, this is going to end up being 1 over m. 1 over m. Okay, that's supposed to be a 45 there. So the idea is to find the slope of this tangent line here. Now we're given 45. Something that we're going to need to know here is, okay, when we plug in 45 into the inverse, we're going to end up getting out, well, we don't know what we're going to get out, right? We're going to get out, I think I was labeling that as B. I think I'm trying to remember that introductory video there. We were labeling that as B, is what we were doing. And we know that if we plug f of b in the function, we get 45 out. So you see, we're going to need to know this is not 45, okay? We plug this number in to the function, that's going to give us into the derivative, and we plug this number in, which I'm calling, what am I calling this? This is b right here, okay, on the x-axis. When we plug b in, we're going to need to know what b is, okay? So we can plug it into the function and get plug it into the derivative and get the slope of this tangent line. Then we can just say, well, it's 1 over m, right? Slope of the tangent line. Anyway, man, I hope that doesn't sound confusing. So this is what we're going to do. We got f of b is equal to 45. Well, here's f. So let's do that. So f of b is equal to 5b squared. Now take this and set it equal to 45, right? 5b squared is equal to 45. Okay, that's what this means right here. We're setting all of this equal to 45. Now we need to solve for b. Now, here's really the method that we're going to be using, because we're going to be doing some of these that's hard to solve. You can't solve for b. It's impossible. So what you want to do is just plug some numbers in. For example, let b equal 1, right? Well, 1 squared is 1, and 1 times 5 is not 45. Well, then let's let b equal 2. 2 squared is 4, and 4 times 5 is 20. That's not it either. What about if b is equal to 3? I think that's actually going to be it, right? Because 3 squared is 9, and 9 times 5 is 45. So there's our b right there. So guess what? We're pretty much done now, because now what we need to do is we want to find the slope of this tangent line right here. So that means we need to take the derivative of this function, right? So let's come down here, take the derivative. So this is f prime of x is equal to, well, not 20, sorry, 10x, okay? Now to find the slope of this tangent line, we go f prime of b, which is 3, and 10 times 3 is equal to 30, right? Whoa, 10 times 3, what the heck? I got the cart before the horse. Race that out of there, sorry. 10 times 3 is 30, okay? Well, that's the slope of this tangent line right here. That's the slope of this tangent line, but we want the slope of this tangent line. All right, slope of this tangent line, remember, is 1 over m, and if this was m, then so this is going to end up being f inverse the derivative. Remember, that gives us the slope of this tangent line right here, and we're evaluating it at 45. So let's go ahead and put 45 in for a, and that's equal to 1 over 30. 1 over 30. Okay, 1 over 30. So it's not too bad. So once you get rolling on this deal, right, just plug in b into this, setting it equal to whatever that number is, and then start plugging numbers in, as you can see, finding out what this b is, then take the derivative of this guy, plug it in, and it's 1 over, and that's it. That's all. There's nothing more. So the whole idea is if we're not given the inverse, we don't know what the inverse is, okay? We don't have a clue of what the inverse is. We don't have to find the inverse. All right, we can just we can use the fact that 1 over m is equal, or is the reciprocal, right, of m right here. And remember what m is. M is the slope of this tangent line, and this is the slope of the inverse, this tangent line at this point, 45. But anyway, it's not that bad. Just practice it a couple times, you'll get it. But it helps to understand it, so you'll definitely remember. So let's go back. So let's remember that 1 over 30. Let's go back and click and make sure. And of course, if you hit the help button, and I'm not sure the help button is going to help you, but all right, we go through. This is basically at 1 over m. This turns out to be m, right? You know, this is a more compact version. So we find b. Okay, as you can see here, that's what we do. Figure out what b is, and then take b, plug it into the derivative of f. And of course, I'm finding the derivative here, and I can't scroll down anymore, but you can see it down here, 1 over 30. All right, so there it is. Practice that, and I'll see you. Go to math.com.